Hello, welcome to DEVCON Summit. Hello, welcome to DEVCON Summit.
I was one of the early adopters, always a fan and advocate of their services. But that morning they let me down. I could not reach the customer hotline. I checked their website, there was no notice. I checked their social media presence, there was no notice of any outage. I tried calling as the managing director, I have access to their VIP hotline, no response. And that was really frustrating. And I later discovered after about 40 days, the outage is actually usual-wide. So maybe an excuse, they were dealing with the late outage. Right-hand side. I think in general, consumers are starting to become very unhappy. Close to half feel that customer service has gone down. Over 40% think that companies ignore their feedback. A little over 1/3 see a decline in product quality. And then quarter look at worsening packaging, talking about consumer goods, everything from potato chips again to iMacs, laptops, etc. So I think the other data point that I'd like to stress is that
data ethics and social impact. His work spans human rights and public health, food security and political risk, and of course, combating disinformation, computational social science. Wow, that's a very nice background, alright? And including the Geospatial Innovation Award in 2023 and recognition from UNICEF Innovation Fund. Let's welcome.
Ladies and gentlemen, developers and games, let us welcome our first tech showcase speaker for today, Mr. Dominic Legal.
Hey everyone, don't worry, my presentation will be shorter than my bio. So how many of you are already building AI systems? Raise your hands. A few. How many would like to build AI systems?
How many are here for the free food?
So sige, I only have a few minutes. So I was asked to talk about ethical AI, but I think the challenge with AI is you have to be a bit of a hybrid. Certainly you have to be a technology person, but you also have to be a bit of a math person, and finding both in one place is a little bit hard. So what I'm going to do today, I promise, is by the end of my talk, you will have an intuitive understanding of AI, especially generative AI. I'll be talking about black boxes. I'll go through a brief history of how generative AI came about. I'll talk about this term called stochastic parrots. Some statisticians call it that. And then I'll talk about how to implement large language models. Because everyone's using ChatGPT, which is great. What about if you want your own ChatGPT in your company? And then finally, the talk is supposed to be about ethics. And most people's impression about ethics is it's something about the law, something about philosophy. That's true. But actually, ethics is also about engineering. This is a very rare time that I can talk about this, because usually I don't talk to techies. So I'm very happy to be here today. First, black boxes. How many have heard the term black box? It's something that you don't understand. So whenever you talk about AI, they often say it's a black box. So if you ever do any statistical modeling, this is what you're doing. Like, this is standard linear regression. Maybe you have 4 variables, and you have an intercept, sorry to remind you about college, and then you have a predicted outcome. Ganyan ang normal statistical modeling. Unfortunately, people from statistics sometimes get confused because they always think, oh, we're going to do AI, it's going to be similar to statistical models. In fact, it is, but not in the way people think. So I would argue standard statistical models are actually neural networks with one node. The problem is, when you talk about neural networks, there's more than one node. There's many nodes. So for example, here is the number 2, a handwritten digit. Each pixel in that digit is a column in a spreadsheet, if you do it that way. 784 columns. And it takes at least 2 layers of neural networks to figure out that that's a 2. Now, what's the difference between that and this? There's a very big difference. One, in a normal statistical model, you kind of already know the features you want to model. In other words, these 4 like circles at the start, that's like 4 columns in a spreadsheet. But in a neural network, you have no idea that certain nodes will light up to make it a 2. Here's another better example. This is the number 9 being modeled by a neural network. The first layer figures out the components of the 9. The second layer figures out that, hey, every time you have a circle and a tail, it's probably a 9. Humans did not tell the model that. It's the model that figured it out itself. And that's why it's called a black box. Because standard statisticians are not used to dealing with models that kind of figure out things on their own. They're only used to looking at weights. And this is something that you as technologists should get familiar with. Yes, AI can be intelligent, but you don't know how it can become intelligent. And that's actually part of the statistical and ethical challenge. So I'll briefly go through how generative AI came to be. Because this is not your usual convolutional neural networks or recurrent neural networks. It's a very different kind of neural network that birthed this technology. How many are familiar with autoencoders? You're an old IT person, you probably know. Sorry about that. So autoencoder works like this. You have an original data, image of a cat, and it's compressed into a small space. And then you have a second model that blows it back up to the original cat, as close as possible. So that's another thing about generative AI. Usually there's 2 models, an encoder and a decoder. This is a simple one, autoencoder. It's used for compression, it's used for encryption, but this is where it all started. So if you have an autoencoder, the secret sauce is this compressed space. Because if you know the data in that compressed space, how it can be blown back up to, let's say, an image or text, that's the key in understanding how large language models work. So autoencoders gave birth to variational autoencoders. It's the same thing, except rather than recreating the original image, you can now query the compressed space. Okay, I want to generate a synthetic cat, and this is what happened. Then I'm sure you've heard of, how many of you have heard of deepfakes? Heard of deepfakes? This is the technology that creates deepfakes. Again, you have two models, generator and a discriminator. The generator creates random data, and the discriminator knows what a real cat looks like. And it will continue to send random data to the discriminator until the discriminator says, alright, that looks like a cat. And that's why deepfakes are very, very good at replicating complex data like an image. But it's actually very random. You cannot control the types of cats being generated. But this is how kind of the last frontier before where we are. So after GANs, we're now at the state of the art, the transformer. So the transformer, similar to an autoencoder, you have an encoder, and it ingests text and positions. I'll explain this in more detail later. And then if you have enough of this, again, compressed space, which represents words and sentences in relation to each other, the decoder reverses the process. Since the encoder learned already, hi, how are you, and all the other words that came with it, the decoder will know, hi, how are you, should be answered by I am fine. That's really what's happening. But to make that accurate, Tom Fisher mentioned hallucinations, you have to have a lot of text. That's why these large language models are large. Because if you don't have enough training data, then all sorts of garbage will come up. But this handles text. There's also another model for images. It's similar to transformers. It's called diffusion. It works similarly. Let's say you have a picture of a cat, and then you have another autoencoder that turns it into a fuzzy image of a cat. But then before you turn it back into the sharp image, you add a piece of data. In this case, an orange cat. Literally the label. So that's now inserted into the data. And you have a new model that now recreates the cat. But since you have this entire process, you can now just send text to this compressed space. Give me an orange cat, and then Stable Diffusion creates an orange cat. So I know it's something very weird and esoteric, but this is the point. If you want to build AI systems, you have to understand both the technology and the users and the math, unfortunately, that goes along with it. But at least develop a vision for it. Okay, stochastic parrots. Have you heard this term? Many people think large language models are just glorified autocomplete. You heard that? All it knows is to give you the next word after a series of words, just like in a search engine. Now, to be fair, that's actually how it started. Large language models, transformers, the original use case was translation. English becomes German, German becomes Italian, and given hi, how are you, what's the next word that comes after that? However, if you still think this is the case, you're missing the entire power of a large language model. Here's a conversation I had with ChatGPT. Here's the process. Get a cup, add milk, add sugar, add coffee, add ice, drink coffee. What's missing from this process? And it tells you, oh, you forgot to boil the water, you forgot to brew the coffee. Forgot to stir the cup, forgot to strain the cup. So your process should be get cup, boil the water, add coffee, brew coffee, add sugar, add milk, stir well, strain coffee, add ice. Can you imagine coding up a decision tree that does this? You need a system that understands process, that understands coffee, that understands what's missing, and can give you suggestions on what's missing. So these are not autocomplete models. They're much more than that. This is actually what's happening in the transformer. I like this article that came out recently by, I think, Financial Times. Each word in that entire data set is modeled against every other word. And then when you have all of these word combinations, it's transformed into, they call it embeddings, which is numerical code representing that relationship. And if you have that relationship, you can now group concepts together. So when you say football, it's similar to soccer. When you have sea, it's similar to ocean. And when you have coffee, it's similar to beverage. This is how these models are thinking. They're powerful, but they're not yet quite AGI, as people say, because all they know is text. I'm sure as you're all listening to me today, do you see text in your head? Probably not, because we don't think in terms of text. We produce text. But these models, all they know is text. So that's the subtle difference between humans and us. So whenever somebody tells you these large language models are just autocomplete, tell them, no, these are models that understand language. And by understanding language, they understand humans as reflected in language. And that's the power in your hands if you're able to develop systems using this technology. Okay, let's talk about implementing. So, first things first, one of the biggest breakthroughs in large language models is it allows non-technical people to perform tasks that used to require technical people. So these two pieces of, one is prompt and one is JavaScript, they produce the exact same output. So this is the power waiting to be unlocked. Can you imagine in a typical company, there's only 5% or less who know how to code. 95% are everyone else who probably have problem solving and process knowledge. The user, as Tom Fisher said earlier, but they don't know how to code. With large language models, you can open the door. They can exercise their problem-solving skills armed with AI. So that's the mission. But first, we have to be very, very careful because of hallucinations. So I think it's already almost a year since ChatGPT launched. And what we're learning is that people like using it like they use Google, like a zero-shot prompt. Like, tell me what's the capital of the Philippines. But the better way to use these models is to give it information first, and then ask questions about that information. For example, have you heard of Chat PDF? No, it's a free tool. You upload the PDF, and you can talk to the PDF. So this is me uploading, I don't think you can see it, Desiderata, it's an old poem. And I can now ask questions of Desiderata. What do you do with loud people? Oh, you should avoid loud and vexatious people because they're harmful to your spirit. Basically, it's quoting the poem to me. Imagine if you upload a CV, which I did. Give me 10 questions to ask about people. Imagine if you upload the entire knowledge base of a company. What could you do with it? So the possibilities here are endless. But you have to be very precise on how you do this. There's currently two approaches. You can combine or do them separately. One approach is called fine-tuning. So you get a base model, which already has been trained by Meta and some of these other companies. And then you get additional data and you retrain the model with additional information. This is usually the best approach if you want an accurate large language model. Unfortunately, it requires a lot of hardware and a lot of power and a lot of time, but the results are very good. And unfortunately, because the time it takes is so long, you're only limited to static data at a time. You can't keep fine-tuning these models all the time. So there's actually a second approach that's a bit more, I would say, forgiving, but less accurate. And we call that RAG. We call it Retrieval Augmented Generation. Which is, before the user gets a response, the system queries a data set. Maybe a vector DB or a Python data frame, and then adds the result to the query. So for example, you ask a large language model, what's the trend of our sales for the past 5 years, and what cost item is causing us the most problem, and how do we fix it? Obviously, the large language model will not know your finance data, but with RAG, you can have a system that retrieves the financial results, adds it to the prompt, and then you get the result. So I think this is where more and more enterprises will be playing at. Your ability to now deploy a large language model, add context from warehouses, vector DBs, etc. And then now you have the equivalent of a Jarvis in the company. And now, the ethics. Obviously, these tools are very powerful. They're capable of many things. But when people talk about ethics, like I started data ethics page almost 4 years ago, people kind of default to social science, philosophy, or basically non-techy stuff. So here I'm going to tell you, as IT people, as technologists, the responsibility for ethics actually all falls in your hands. The problem is we're too busy coding to understand the implications of what we're coding. First problem, these models make mistakes. Chihuahua or raisin bread? Coffee or bagel? Right? So what do you learn here? Your model is only as good as the data you fed it. If your data is not good, then your model is bad. But the data is only as good as the process that created the data. And how you know? I've never seen an IT person that's involved in process re-engineering. That goes to the project managers or the business managers. But you guys have to get into it, as Accenture said earlier, get into the business, because it's the process that creates the data that you will code. Second, this is a bit more subtle. At any given point in this chart, the red line, which is the forecast, was wrong. Right? Until you finally get all the data. So what's the lesson here? No matter how good your model is, you will never capture all the data. So you always have to allow for a margin of error. And most importantly, this diagram is all about model drift. In other words, you train a model on Monday, by Friday, it might already be out of date because the environment has changed. And that's why we have to implement data and AI governance. There has to be a regular refresh of the model. Otherwise, you have models that are giving you wrong outputs. So the phrase here, I think this came from IBM. All models are wrong, but some are useful. But the usefulness of the model is in your hands. Next, this is a bit more Hollywood, but it is a classic problem in computer science. This is an agent controlling a boat in a racetrack. And it was given a goal, please maximize your high score. So what the agent figured out was the best way to maximize the high score was never to finish the race. It was to keep picking up these bonus items as it kept respawning on the game. So this is a subtle problem in computer science. Every time you have an automated process, you have to be very careful of the goal that you give the automation. Otherwise, it might solve the automation in a way that you never expected. For example, we have a hospital run by AI. The doctor says, let's minimize cancer cases. AI will say, okay, I will kill all the cancer patients. And we will achieve that goal. Be careful, we're near that point already. We're implementing these systems everywhere. This is the Terminator problem. So, automation can achieve an outcome, but the outcome might not be aligned. So I'll give you a little trivia of how ChatGPT solved that. So you now have a large language model that can predict the next word, but it was useless. So what they did, apparently they hired 10,000 people in Kenya and gave them lots of questions to answer. So the Kenyans were answering questions, and they stored the answers in another model. And then they asked the model again to answer the same questions. And the model was giving these answers, and then the Kenyans were supposed to score how well the model answered the questions. So you now have a third model. And then finally, you had one model answering questions, and the other model that gave the score. They kind of fought each other, like a GAN or like an autoencoder, until the score was maximized. So they call this process reinforcement learning through human feedback, which in a way was a way of solving for that alignment problem. So now you have a model that doesn't just predict the next word, it can answer a question. But that actually didn't solve the problem, because who knew what the Kenyans were writing in terms of answers? Who knew if they were politically biased? Who knew if the answers were actually wrong? And it doesn't mean that if it answers like a Kenyan or a human, that humans are actually correct. Actually, humans fight each other all the time. So by attempting to solve one problem, they've introduced another problem. So this is still an open-ended issue, and that's the hallucination problem. I have about 2 minutes left. This one is a bit more subtle. I don't know if you're familiar with this. So this is the picture of a solar system. This one is with the sun in the middle of the solar system, and this one was with the earth in the middle of the solar system. This is before Galileo. Here's the punchline. Both of these images are correct mathematically. The difference was the premise. In other words, you could solve for the floral pattern of Mercury going around the earth. Calculus can solve it, but the premise was wrong. Second example, I'm sure you've seen this. This is called Anscombe's quartet, statisticians. So each of these charts have the same statistical value, same regression, same average, same mean, same variance. But you eyeball the dots, they're completely different. So what's the problem here? Math is not reality. It's just a representation of reality. You still need business knowledge. Otherwise, you would believe that Mercury was moving in a floral pattern around Earth. So this is a reminder to all of us here. Even if you have the best technology, even if you have the best math, if your business assumptions are wrong, you're wrong, right? So you have the wrong conclusions even with the correct math. This one is a bit more subtle. You heard of Dunning-Kruger? It's a study in the 90s. They proved that the more confident a person is, the less they know. And this is actually true in tech. You start from no knowledge, and then maybe you know how to code a little bit of React and Angular, and suddenly you're the best technologist out there. Until you get humbled by experience. So even if you start knowing more, you actually never get as confident as you will ever be back in the past. I think everyone of us has gone through the same cycle. Always stay humble, no matter what you know, no matter what you've done, because there's always someone better than you. Okay, I call these the cautionary tales about how to time. This is why AI is not easy. This is why my parting message here is that we all need to come together. We need to learn this technology. We need to humbly understand it. This is not the time for big grand titles and status. This is the time we have to admit that we actually don't know where we are now, but there are clues. And if we do that, who knows, we might avoid the mistakes of past technologies that have gone through that hype cycle. If you notice, the hype cycle follows the Dunning-Kruger graph. It's not a coincidence. The reason you have hype, if you have a lot of people confident about something they don't understand. So that's my talk. I hope you enjoyed it. I'm a little over time. And if you're interested, please approach me online. I have a research platform. You can take talk. Just look for Talk Leader. Thank you very much to DEVCON. This is my first time. Hopefully not the last time. Thank you.
Opportunities in the tech community. So our invited speakers, our invited tech leaders, will talk about it, or will talk about all of it today. Dito na mismo sa White Space Makati sa DEVCON Pro Summit 2023. Okay, our first panel discussion.
Okay, so let's call these friends and this Dr. Charlie and Beauty Content. Alright?
Okay, so our panel speaker, Ms. Bea Luz R. Valbuena, the Executive Director at School of Computing and Information Technologies at Asia Pacific College. Ms. Pat Damarino, the CSTA Philippines President and the DEVCON Kids Founder.
Of course, Dr. Charlie Head for Research at AI, with the Everyday Contest, you have Education PH, and our panel moderator, Philippine Digital Countryside Advocate and Consultant at Center for Digital and Innovation Sustainability, Executive Director of DIGEN's ICT.
Alright, so developers and geeks, welcome to panel discussion number 1. Let's give a big hand to our panel speakers and moderator.
Alright, good afternoon everyone. Thank you so much for investing your time for this Friday afternoon. My name is Justin, and today we welcome you to the DEVCON Pro Summit 2023. But before we start, I want to give you some brief overview of what DEVCON is and why we have this event. So DEVCON Philippines is a non-profit organization that has been empowering geeks for good for over 14 years. DEVCON is the Philippines' largest community and tech non-profit organization of technology experts, developers, and IT enthusiasts. The DEVCON Summit Series is one of the pioneering software developer conferences in the Philippines, organized annually since 2011. This 2023, we're separating the events for IT students and professional developers to bring a more specialized program experience. And for today's event, which is DEVCON Pro Summit 2023, we are featuring the theme Technology for Impact. and subject matter experts whose expertise, technologies, practices, and advocacies have made a significant impact in our industry, economy, and society. Now, let me introduce to you our amazing panelists for this afternoon, who have been leaders in the tech industry. So let's start with Mr. Tom Fisher, a senior executive with accomplished international track record in developing, implementing, and delivering high-tech solutions. He has held leadership positions such as CEO of EV, led technology teams at Qualcomm as CIO of CDMA Technologies, and served as CIO and VP of Cloud Computing at SuccessFactors, now Sun. Next in our panel, the founder and president of DEVCON Philippines, which is Mr. Winston Damarillo, Silicon Valley veteran with 3 successful startup exits, a former venture capitalist at Intel Capital, and a young global leader of the World Economic Forum. Our third panelist, Mr. Arvin Yanson, a seasoned IT leader with over 2 decades of experience, currently serves as the managing director at Accenture. He specializes in driving innovation in various technology domains, including analytics, IoT, artificial intelligence, and human-centered design. His expertise spans a wide range of areas, from communications and billing to customer care and automation, making him a valuable asset in the IT industry. We also have Dr. Ligot, Doc Ligot, a CTO at Serialytics, a social impact AI company and an AI ethics advocate. He is the founder of Data Ethics PH and is on a mission to make AI understandable and responsible for all. With the diverse background as a data analyst, researcher, software developer, and technologies. So let's give it up for our amazing panelists. I'll hand over now, I'll open the floor now for questions, or if you have any. Do you have? Yes? Sure.